All right, so let's see where we're at. All right, so this is where we're starting up with today. So far, we've done quite a few things. We've been doing reflection in X and Y axis, reflection in special lines, such as Y is equal to X, Y is equal to minus X. We've even done enlargements. But so far, we have not done any rotations. We have not rotated any shapes. Now, if you look back on the first week of notes, right? The first week of notes, I would have given you all a formula to do rotations. And I want you to find the first set of notes. I want you all to confirm there were two formulas to do rotations. Take a few seconds, go back in the notes, and confirm that there were two formulas to do rotations. Let's take a 20 seconds and confirm here. Whenever you are doing a rotation, I think this is probably one of the harder ones, and you will need a scientific calculator, one with sine, tan, and cosine. Well, in life, right, there are only in a 2D space, there are only basically two ways to rotate something. It's either you can rotate something clockwise, this direction is clockwise, or the opposite. You can rotate it anti-clockwise or anti-clockwise or counterclockwise. And those three things mean the same thing, right? So it's either you're rotating something clockwise or anti-clockwise. Do you all notice that there's a slight difference in the formulas for clockwise rotations and anti-clockwise rotations? Look at it carefully, because I used to confuse that in school, but nobody never really took the time to point out that there was a slight difference. They basically just threw it in front of us and said, hey, you have to learn that, right? There is a slight difference. So when you're doing the questions in the exam, you have to make sure and read it properly, right? So if I ask you to rotate something anti-clockwise, that means this direction, right? And you will notice that this one here to the upper right-hand side, it has a minus by the sign. The clockwise one, the minus sign would actually be down here. That's a slight difference. So anyway, let me show you how to go about this question. So they gave you a triangle and the examiner says, hey, you need to rotate this anti-clockwise, and they have to tell you how much degrees. In this particular question, it's 90 degrees. And this formula only assumes that you're rotating it about the origin. Now, I didn't write that piece of the instructions, but the examiner is supposed to spell it out for you, because this formula, and if you look back in the notes from 2 weeks ago, it only works if you are rotating it about the origin, which is 0, 0. So I know the question people have already. Suppose they ask you to rotate it and it's not about the origin. Is there a formula to do that? Yes, there is a formula to rotate something that is not about the origin, but that formula is no longer on the syllabus. If they ask you to rotate something about not the origin, you don't use a formula, you use a procedure, a drawing procedure. And I will make sure and show you an example of that today. So what we have to do, get your calculators out and do me a favor. On the screen of your calculator, make sure you see the letter D or D-E-G. Make sure you see that, right? If your calculator is not on D or D-E-G, you will need to figure out how to change it. I'm not going to be able to assist you with that because everybody's going to have a different type of calculator. But if at the top of your calculator, you're seeing R or R-A-D or G or G-R-A-D, something is wrong and you need to try to fix it. And one way is you could turn your calculator around and look for the reset button, right? Make sure and see if they can resolve that issue first of all. Right. So if they ask you to rotate it by 90 degrees, you see these funny looking symbols here in the formula, the red things, that's theta. You have to replace that with the angle they gave you. So if they ask you to rotate it by 90 degrees, you put cos 90 minus sine. Let me write this a little bit. This could get a little, let me write it here. Cosine 90 minus sine 90, sine 90, and cosine 90. You see what I did? I just went to the formula and replaced the theta symbol with whatever angle they told me to rotate it by. So everyone at least do that for me, right? Cosine 90, obviously there's a space here, then minus sine 90. Whenever a minus sign comes first, if you look at your calculator properly, there are two minus signs on your calculator. The normal minus sign, right, that allows you to subtract, or there's a positive / negative button on some calculators, and some calculators have a minus sign in a brackets. You're either using this or you're using this. You're not using the regular boring minus sign when a minus sign comes first in a formula. Okay? Right. So do you all think you all can summarize this for me? Type in cosine 90, that will give you a value. Type in minus sine 90, it will give you a value. And the same thing here and here. In other words, when you type in all four on your calculator, one at a time, you're going to get 4 values. Tell me what those 4 values are. Right? If you're getting a whole set of crazy decimals, it's because your calculator is on the wrong mode. When you simply type in, you press the cosine button and type 90, you're literally just pressing the cosine button and typing in 90 right after. And when you do that, cosine 90 is 0. So cosine 90 is 0. Minus sine 90 will give you minus 1. Sine 90 will give you positive 1. And cosine 90 will give you 0. Right? For those who are not getting the values, I could stay back after class and I could probably try to load up a calculator I have here and show you how to press it. But let's take my word for it for the time being. I can't show the calculator and the PowerPoint slide at the same time. My software does not allow me to do it. Okay? Right. So the 4 values that we get are 0, minus 1, 1, and 0 when we type in this on the calculator. Now they want us, now that we have the correct matrix on how to rotate this triangle by 90 degrees, guess what you guys are going to do? Just like last week, we have the correct matrix now. We have to visit all the points. Let's call this one on top here A, this one B, and this one C. All you have to do is take this matrix, 0, minus 1, 1, 0, multiplied by point A, which is 4, 6. Remember, when you are multiplying the matrix by the point you have to write it vertical. The X coordinate goes on top, the Y coordinates go underneath. And you apply that matrix to all the points. So take this matrix, multiply by A. Then take the same matrix, multiply by B. And of course, repeat the procedure for point C. Do you all think you all can finish that out for me? I'm not going to be doing the multiplication of matrices today. That's on you today, because you had 2 weeks to come fully prepared on how to multiply matrices. For A prime, when it's 6 swings up to the top and you do your multiplication, did you all get minus 6, 4? Does that look correct? That A prime is minus 6, 4. Looks about correct? Great. And you're going to apply that same matrix now to the point B, who is 7, 1. Right? So point B is how much? 7, 1. And of course, when you take this matrix and multiply by B, you're going to get B prime. Give you a minute again. For B, I am getting -1/7. -1 for the X and 7 for the Y. Well, a lot of people are sending me the answers, so I know you're getting through. The majority of students are getting through. So you just have one more point to do, right? Point C. Now, I know some of you will probably see a pattern with the points, right? But I'm not going to give away the pattern because the examiner is going to want to see all your working in the exam, right? You have to put some work in for the examiner. You have to put in something for it, right? You know how examiners are, right? Right, so point C is 4, 1. And when you multiply it by that matrix, you're going to get -1, 4. I hope that's correct. -1, 4. Now it's -1 on top, not -4 on top. Let me double check that. Yet it's -1 on top, I'm sure. All right, so once you get your 3 points, let's plot those 3 new points, okay? A prime, -6, +4, right? I'll go put in the values after. B prime, -1, go up to 7. That's up here. C prime, -1, look at there on the X, and we go up to 4. So we put in the values here, right? -6, 4. On top here is B prime. Down here is C prime. -1, 4. Let me write that out of the way. Something I want to do here. All right. And when you connect these, now, I don't know if you all can imagine this. Can you all imagine that being a rotation of 90 degrees? Does that look like a rotation of 90 degrees? There's a way to prove that that is a rotation of by 90 degrees anti-clockwise. I can prove that to you. Let me prove this to you. In case you want to check to see if your answer is correct, because it's kind of hard in my head to visualize a rotation. Let's prove that this is a rotation of 90 degrees anti-clockwise via the origin. What you need to do is choose any point. You can choose either A, B, or C. Really doesn't matter. Let me choose point C. All you have to do is take 1 point at least, just to test run it to make sure you're on the right track. Since it's a rotation about the origin, take point C and connect it to the origin. So I'm going to connect it to the origin, because that's the center of rotation stated by the examiner. When you connect it to the origin, let it bounce back to the point it became. Remember, C became C prime. Connected to C prime. Does this angle look like 90 degrees? And look at it. If this pink line were to turn 90 degrees anti-clockwise, isn't that arrow going anti-clockwise? Doesn't that angle look like 90 degrees anti-clockwise? So you can do that to prove it to yourself, but sometimes the examiner asks you to prove it. You say using a drawing method, prove that it was rotated by 90 degrees. And you could choose any point. I can prove that I go with our next point. Let's choose another point. A. If I take A and connect it to the origin, I'm using a different color here. So it hits the origin. And then I connect it to A prime because A became A prime. Doesn't that green angle there look like 90 degrees? Think about it. That's 90 degrees. and it rotated by how much degrees? 90 in an anti-clockwise direction. I'm not going to do point B. It will just make the diagram look too cluttered. Okay. So everyone can visualize. Well, you don't have to visualize it now. It's on the screen. You can physically see that it's being rotated by 90 degrees anti-clockwise. Don't worry, guys. I have more than one examples of this. I don't think I would just do, right, one example. In the exam, if they ask you to prove it's a rotation of 90 degrees after you do the calculation, and the examiner physically writes that, then you have to draw the lines. You can just draw one. You can either draw the pink one or the green one. If they did not ask you to prove it, you don't have to draw the lines. But I usually draw the lines in the exam to prove it to myself, so I can leave the exam knowing that I got the question correctly. It's for my mental health, in other words, when I leave the exam. All right, guys, so let's move on, right? You will see more examples of this coming up. Right. All right. So I already did both, right? It looks like it didn't change, right? Sorry about this. So remember, oh, this is what the answer was supposed to be look like. This is a better way of doing it, right? Sorry guys. I showed you both methods already to just do it, and then I showed you how to prove it to yourself. So let's move on to the storyline. So you all remember Jenny, right? Anybody remembers the name of the wealthy baron she's being asked to marry? Anybody remembers the name? Remember his name was Amma So Smelly. Amma So. It was supposed to be. You all remember it? It was supposed to sound like he's so smelly, whatever. Anyway, let's see what happens when I didn't get Jenny to rap this one. I was unable to do it, right? But anyway, let's see how the marriage proposal goes between two of them, right? I have a good feeling Jenny doesn't want to marry Mr. Amaso Smelly, all right? So he says, marry me. She says, no. Says, marry me, please. And she's a rapper. So she says, I would rather die of some disease. Right? Then he says, I'm telling everyone you're a witch. And then she raps back and says, oh man, I always knew you were a snitch. Remember, she can talk to rats, right? So that scene seems as witchcraft back in those days. All right, so the Baron is going to tell everyone that she is a witch. Well, what do you think is going to happen to Jenny if everyone finds out she's a witch? Well, what would happen in one of those normal movies if someone is accused of being a witch, right? So they usually do bad things to you, right? They will probably burn you at the stake. They'll probably hang you. They don't, you know. So Jenny is in a lot of trouble. So I don't know how she's going to get out of this one. And he's a wealthy baron. He has a lot of influence on the people around him. All right. So this one here, let's say they wanted, remember the same question we just did. Let's say they wanted you to rotate it anti-clockwise again, but they did not want you to use matrices. Do you all think it's possible to do the same exact question we just did without using matrices? Well, what are your thoughts on that? I think the answer is yes. And I kind of showed you how, I kind of partially showed you how to rotate something by 90 degrees without a matrix. I kind of did it on the low, but let me say it back, right? So they take away a calculator in the exam and say, hey, rotate that by 90 degrees, no matrices. So here's what you need to do. Let's put back the points, A, B, and C. I think those were the 3 points, right? All you have to do is take your ruler. Let's start off with point A. And all you have to do is take point A and using your ruler, draw a straight line, hopefully straighter than my line here, to the origin, because we're rotating it about the origin. What you need to do is measure the length of that line accurately. Yeah? So if it's 10 centimeters, make sure you measure it properly. Let's assume that this line is, when we measure it, we get 11 centimeters. Let's just say if. Then, using your protractor, you'll remember what your protractor is, the semicircle like this, that you would have gotten in Form 1 when they make you buy that $18 geometry set. Hopefully, it didn't cost you more than $18, right? What you need to do is use this and measure exactly 90 degrees. And when you measure exactly 90 degrees, right, you are going to draw that line at 90 degrees. And how long you think this line will be? I just ask him, how long do you think the new line has to be? 11 centimeters, correct, right? So you just to reiterate, you take point A, connect it to the origin. You measure the length of that line, measure it accurately, use your protractor, measure 90 degrees because they ask you to rotate it by 90 degrees. And then you draw a line in that direction at the same exact length. And you do that for all the points. So you do the same thing for point C. Take point C, connect it to the origin. And the reason we are connecting it to the origin is because the examiner said in the question, the center of rotation was the origin. That will be physically written in the question. Let's say the length of this line is 6 centimeters. You use your protractor, you measure 90 degrees and draw a line 6 centimeters in that direction. And you do the same thing for what? Point B. You all could see this becoming very messy because the lines are going to what? Start overlapping each other, right? Right? All right. Remember, we are pretending, right? So do you all understand the concept that there are 2 ways to do the questions from about 2 or 3 slides ago, that there are 2 ways to do the same exact question. You could use matrices or you could use a drawing method. Obviously, you have to read the instructions in the question to know which method to use, and you have to follow whichever instructions. If the examiner does not tell you which method to use, obviously you could use any method. Now, which one would you all prefer? Let's say I am the examiner and I say, just rotate it by 90 degrees anti-clockwise about the origin. Which one would you faster run to? The drawing method or the matrices method? I'm just interested. There's no wrong answer here. Right? I'm just telling you my personal preference, what I would do in an exam. I would use the matrices. The drawing method, and you all can measure wrong by mistake. Doesn't the drawing method have more room for error? That's just me. Because if you're not super neat, you're not going to get the correct answer, you know, right? Let me see if I have this animated, right? Right, look at me animate this. So you see the first point, this point here. I'm going to put back the A, B, and C. A, B, and C. You see what I did? I took point C and I connected it to the origin. And then I drew a line at 90 degrees at the same length. Then I'm going to do the same thing for what? Point B. That's the red line. And then measure 90 degrees with my protractor, and notice the 2 red lines are the same exact length. And I have to do the same thing for point C, for point A, sorry. Take point A, which is the blue line connected to the origin, measure 90 degrees with your protractor, and it ends up here. And then you connect all 3 points. Right? A lot of people like to use dashed lines. You don't have to use dashed lines, but to me, the dashed lines look neater, okay? And also in the exam, you will not have different colors. You're going to have to use a pencil to do everything. So unlike here, how everything is going to be the same color in the exam, it's going to be harder to make it harder to draw, because now you're going to have to make sure and be super careful not to mix up your lines, right? All right. You're going to see another examples of this. So let's move on, right? All right. So before we move on here, right, I just want to answer another question. I'm getting too much, right? Just one quick thing, right? All right. All right. Great. So let's see what's going on with Jenny here, right? Obviously, that's Jenny. She has her wrapping cap on, right? So let's see what goes on. Let's see. So the villagers gather to hang her, right? Because she's a witch, right? They're all superstitious and whatnot, right? Let's see what goes on here. So the bitter nobleman, but as obvious, right, convinced the town that Jenny was a witch. They drag her to the gallows, and poor Jenny is being hanged, right? However, lucky for Jenny, the noose wasn't tied properly, right? So that's some good news there. Right. All right, so poor Jenny, she's going to die. Let's hear her rap, her final rap before she meets her maker.
Yo, I'm gonna die. Didn't even get a chance to testify. Gonna see God in a while.
I don't know, how would you rate that rap from 0 to 10? Right? Somebody say -0, which is not a real number, right? There's no such thing as -0, but thank you. All right. Oh, I also forgot to mention, right? On this scale of 1 to 10, 10 being the worst, 1 being the best. So I would like to thank you all for this, for the great ratings that you all are sending here. Sorry, I didn't explain that to you all. All right. So anyway, the townspeople were too lazy to stay for the execution. I guess they see this every single day in their lives. All right. So they all leave, and it's only Jenny and the poor mouse left. We'll see what happens. Remember, Jenny's most prized possession when she was living was cheese, and we're going to figure out why just now. All right, so here's what. You think this question here, I did not make a mistake, because somebody's going to tell me I made a mistake, but I did not. Suppose they ask you, right, to rotate it by 180 degrees. Do you all notice that I did not say whether it was clockwise or anti-clockwise? How much of you all noticed that in this particular question, I did not mention whether it was clockwise or anti-clockwise? And you all know why. Let me explain why, okay? Let's say you have a point here. Let me say you have a hinge, right? And you have a piece of board connected to the hinge. Remember, this way here is anti-clockwise. I'll put CW. And if I spin it this way, it's clockwise. If I ask you to spin this 180 degrees anti-clockwise, does it not look like 180 degrees? Won't it end up on this side here? But if I ask you to do the same thing, but I ask you to spin it clockwise, so this pink piece of board here is this way, and if I ask you to spin it clockwise, won't it end up in the same exact space? Think about it. If somebody were to ask you to spin 180 degrees, so let's say this is your head here, and you are facing north, and they ask you to what? Spin 180 degrees. Won't you end up facing south, it doesn't matter which direction you rotate by. If you are facing north and you spin 180 degrees clockwise or anti-clockwise, you're going to end up facing south. So in 180 degrees, seeing whether it's clockwise or anti-clockwise is irrelevant, right? Right. So when it comes to spinning 180 degrees, you could choose any one of the formulas. You could choose the anti-clockwise formula for rotation, or you could choose the clockwise one. Both of them going to give you the same exact answer. This formula here, though, I'm just asking, is this the clockwise rotation formula or the anti-clockwise rotation formula? Just confirm that for me. Like I said, anyone is going to give you the same answer. This is the anti-clockwise. So I'm just going to choose the anti-clockwise formula, and you're going to get the correct answer. You think you all could do this question for me? Since it's 180 degrees, go and replace all the thetas with 180 degrees for me. So this is what you're basically writing in your books. Cosine 180 minus sine 180, sine 180, cosine 180. Type in these four things one by one on your calculator and tell me what four values you get. And then you're going to take those four values and multiply it by point A, then by point B, and then by point C. So I'm going to give you 5 minutes to do this question. Of course, I'll throw a little assistances as I go along, right? Not too sure if assistances is a real word, but who knows? So, right. So for point E, I am getting 2 minus 6 when I apply it. For B prime, I am getting 2 minus 2. And for C prime, 8 minus 4. That seems about correct, guys. When I took point A and multiplied by the matrix, point B multiplied by the matrix, and so forth. Right? So. All right, so let's plot these points here now. E is how much? Oh, I had to get rid of this thing here. Really. It's blocking my view here. Right. Let's see. A is 2 minus 6. So point A prime will end up down here. B prime is 2 minus 2. B prime. And C prime, 8 minus 4. It ends up somewhere down here. And when you connect it, that's your rotation of 180 degrees. Of course, clockwise or anti-clockwise is irrelevant. All you know is that the center of rotation is the origin, which the examiner is supposed to state in the exam. Right? So how much of you all got this entire question correct, right? The biggest headache here is to multiply of the matrices to each point fast. That's the hardest thing to do, but that is what the homework was about, right? To make sure that you came prepared today to multiply matrices properly. Right? So some people said they got all 3 correct. Some people said they get 2 out of the 3 correct. Oh, that's still good. Right. All right. So how would you do this question if they ask you not to use matrices, right? Now, this is obviously the answer we got just now. Do you think we could rotate something? Do you think you can rotate something by 180 degrees, right? Without using a matrices method? But what's the obvious answer to that? The answer is what? Yes, right? Because there is a drawing method to do. Now, as you all remember, 180 degrees. Do we all agree that right? Right? It is a straight line. Do you all know that a straight line is 180 degrees? So it's not like 90 degrees, right? Like where you would draw a line like this and you make a 90 degrees if they ask you to rotate it by 90 degrees, okay? So here's what we're gonna do. In the exam, you're gonna have to take out what? Your rulers, right? And remember, it's about the origin. So let's just call this point A, point B, and point C. All you have to, let's start with point C. You take your ruler and connect it to the origin. So let's say the length of this line is, let's just say 2 centimeters. But obviously you have to use your ruler to measure it what? Accurately, right? Then what you're going to do is continue that line, right? I'm going to draw a dash, right? What is the length of the dash line? Well, what do you think the length of that dash line should be? The same exact 2 centimeters, so it's another 2 centimeters. But you see, it's a straight line through the origin. And let me just say back why it is a straight line through the origin, okay? Because the center of rotation is through the origin. That would have been stated in the question, and 180 degrees is a straight line. Guess what you have to do now? You have to do the same thing for point B. You take B and connect it to the origin. You measure the length of that line. Let's say it's 7 centimeters. What you need to do now is continue that straight line for another 7 centimeters. So this is another 7 centimeters. And you have to do the same exact thing for point A. Take point A, connect it to the origin. And let's say the length of this line is 9 centimeters. Continue that line in a straight line fashion for another 9 centimeters. And then the lines will end up at 3 points. Guess what you do? You connect those 3 points. And of course, this triangle is the answer you will ultimately get. Okay? Y'all think y'all understand that? That a straight line, I think this is best I can explain it. I don't think I can do better than that. All right? I'm hoping I have this animated. So I'm really, really, really hoping I have this animated. And let me click on this slide and let me see what happens, right? For some reason, it's not changing just now. No, sorry, I don't have it animated, right? So for those who need to see it, I just put it back on the screen just for a few seconds so you could, internalize it. Right, so I was asking which one to use, right? Only one person correct me and is basically telling me the answer is none of them. I'm trying to trick you here, guys. Anybody on YouTube figured out that I was trying to trick them? We don't use any. These formulas only assume that the center of rotation is the origin. You can only use those formulas I gave you 2 weeks ago if the center of rotation is the origin. Is the center of rotation the origin today? It's not 0, 0. The center of rotation is 1, 4. So these formulas are irrelevant. Those formulas cannot help you. All right. So the only way to do this question when the center of rotation is not the origin, you're forced to use the drawing method. And you notice the examiner told you to use the drawing method because I wrote this question. The examiner might not be so nice in the exam to remind you that you have to use the drawing method. You have to know by default that if the center of rotation is not the origin, then you have no choice but to use the drawing method. So let's use the drawing method. So in case you all don't know this, right? A protractor, a normal cheap protractor, I'm talking about the semicircle. What's the most amount of degrees a semicircle protractor can go up to? 180. So can you use a protractor easily to measure 270 degrees? You all see a problem there? You're not going to be able to use a protractor. Well, I mean, you can use some techniques and hacks and whatnot to get 270 degrees, but that's going to be a problem. But let me show you a trick. Let's say we have north, east, and south. I think this is going to be real easy for everyone. So you have north, east, west, and south. All right. Let's say I ask you to turn 270 degrees clockwise. Let's say that you are facing north. So you start off with north. And I ask you to spin clockwise, like in this question here, clockwise 270 degrees. Which direction will I end up facing? If I turn 270 degrees clockwise, I'll put CW here. West, right? I think that's because every section of the cross is 90 degrees. So if I spin 270 degrees, right? That's 270 degrees clockwise. I end up facing what? West. Is there an easier way to face west? Instead of turning 270 degrees clockwise, if I'm at north, couldn't I just spin 90 degrees anti-clockwise? You'll realize that in both instances, I end up facing west. Which one do you think will be easier? Well, less tiring for you. The 90 degrees anti-clockwise. So that means whenever the examiner asks you to spin 270 degrees clockwise, using a little bit of common sense, right? You know that 270 degrees clockwise is the same exact thing as 90 degrees anti-clockwise. Okay? Everybody with me so far? Everybody good there so far? And obviously 90 degrees anti-clockwise, you could use a protractor to measure that because a protractor goes all the way up to 180. So 90 degrees could definitely what? Fit. So that's a little trick you have to know in the exam, right? If the amount of degrees is more than 180, minus it from 360, because 360 minus 270 will give you 90. It will be that amount in the opposite direction, right? Right? And you will not, obviously, you will not be penalized for doing that. That is, in fact, that is exactly what you're supposed to do in the exam. The examiner is testing you, right? To see if you actually know that there's an easier way to do that rotation. That's actually the trick in the question. So let's do this, guys, right? Let's call this point A, point B, and point C, right? Let's start off with point A. To rotate it by 90 degrees anti-clockwise, because I'm going anti-clockwise, but 90 degrees, I'm going to take point A and connect it to the center of rotation. Remember, the examiner told us the center of rotation is 1, 4. So let's say the length of this line, the green line, is 11 centimeters. Remember, you have to take your ruler. Do we all agree that we will have to move downwards? 1, 2, 3, 4, 5, 6. I think we'll end up downward. I'm not too sure where we're going to end up, right? But the point is, this line and this line is supposed to be the same length. Let me just make sure. This green line is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The length of the green line will also be what? 11 centimeters. Do we all agree that this is, look at this line. If this line starts off here and we turn, do we all agree that that is 270 degrees clockwise? Isn't that the same thing as 90 degrees anti-clockwise? You all see it? I could use my protractor to measure that 90 degrees. So instead of using my protractor, which I'm not going to be able to in any case, to measure 270 degrees clockwise, I simply use it to measure 90 degrees anti-clockwise, which is the same exact direction we want to go. And we do the same thing for point B. We take our ruler from point B, draw it to the point of rotation, and we move it the same direction downwards. 1. And this is where point B is going to be. Here's point A prime, B prime. And we have to do the same thing for what? Point C. Take point C, join it to the center of rotation. Whatever length this line is, we measure 90 degrees in the opposite direction. So if the length of this line is 6 centimeters, then the length of this line is 6 centimeters, 90 degrees apart. And when we connect that, it will look like a rotation of 270 degrees clockwise about the point 1, 4. The point is, when you connect it to the center of origin, we measure 90 degrees and move the same exact length in that direction. It at least 60 or 70% clear so far? Whenever the center of rotation is not the origin, you have to use a drawing method. You must use a drawing method. Take a look at it. Take a look at it. I know it's a bit complicated because it has so much lines on it. Right. So we're going to start off with, let's call it points. This is A, this is B, and this is C. Remember, the center of rotation is this dot here, which was given to you by the examiner. We're going to take point B and connect it to the center of rotation. We measure the length of that line and we move it downwards, because if we move exactly downwards, that's 90 degrees. Then we do the same thing for point A. We connect A to the center of rotation, measure the length of that blue line, move it 90 degrees downwards, because 90 degrees is the same thing as 270 degrees clockwise. Then we do the same thing for point C. Connect C to the center of origin, measure 90 degrees anti-clockwise, move it the same length. Then connect all 3 points. Right? You'll realize this is 90 degrees. When you move horizontal and downwards, that's 90 degrees. So, right? Everyone think they understand it a little bit better now? Using, well, this is obviously neater than how I would have drawn it, right? So we connecting it to the center of origin and the center of rotation, sorry, and moving it by 90 degrees. All right, so let's have a look at it just for a few seconds, right? Make sure you proceed. All right, so let's continue with the storyline, and hopefully after this one is another, I'm hoping there's another example where we do a rotation where it's not the origin. So anyway, let's see what's happening with Jenny. Obviously, they need to flee the country, right? Because remember, she's branded as a witch now, right? She can't be seen there anymore. So Jenny fled to France, from France. Remember, she was from France and sailed to Spain. Obviously, if she goes to Spain, right? Remember, it's a small world, right? Do you think that someone could recognize her? Do you think it's a good idea for her to get a disguise? She needs a disguise, right? Remember, if somebody recognizes her, they'll call the guards for her. They'll, she's a witch, right? She's a wanted person. So she's going to need a very, very, very good disguise. So let's see her disguise. Ah, perfect. No one will ever, ever, ever recognize or know that is Jenny. All right, perfect. So now the mouse is demanding his cheese because Jenny signed a contract, and that's the end of this particular story, guys. So I guess Jenny did have a happy ending. This one had a happy ending. My previous stories didn't have happy endings, but this one is a happy ending. All right, so let's move on. Let's see what the next slide is about. Let's see what this one is about. Well, someone asked how Jenny died. Well, I guess she just died of old age, right? So, all right. Oh, sorry, guys. Before we move on, how much of you all reached the third part of the homework? This is actually a Form 2 subject, like how to bisect a line using a protractor. Most people would have done this in Form 2 or Form 3. How much of you all remember how to do this or actually saw the homework to know how to bisect a line? Let me know in the chat there. All right. So this is something I have two ways of showing you or to refresh your memory on how to bisect a line. I am going to do it physically, like using whatever I have here. And then I have a video to show you. And hopefully after you see that, you will know eventually how to bisect a line. To bisect a line means to be able to cut a line exactly in half. So let's say you have a line here, the line AB. It starts at A and ends at B. And you want to cut that line exactly in half, okay? What you need to do is take your compass. Your compass is this here. The thing that has a point on one end and the other side holds like a pencil. No? But I know everyone here should know what a compass is, right? A drawing compass, right? Great. So all you have to do is take the compass and open it to a little more than half the line. So you put the needle here, that's the sharp part of the compass, and you open it to a little more than half the line. You just have to approximate it in your head. It cannot be less than half the line. Some people just go all the way to 3/4 of the lines. Once it's more than half the line, it will work. So what you do is open it to a little bit more than half the line and you scribe an arc. Then you go to the other side of the line, make sure not to alter the compass, make sure it remains open the same amount. At point B now, scribe another arc. Obviously, the two arcs will meet at 2 points. It will meet here and it will meet here. All you have to do now is take your ruler and connect those two meeting points. You see this green line here? That will cut the black line, the original line, in exactly 2 equal pieces. So I'm just saying, if the length of this line, the black line, was 9 centimeters, I just say 9. This portion would be exactly 4.5, and this portion would be exactly 4.5 centimeters. All right. Now, I have to make the assumption that you did this at least in Form 2 or Form 3. Right? Remember, when you teach in a class, you have to make some assumptions. But just in case, I have a video animating this whole process. So let me get to the video, and hopefully that after seeing that, everybody will be 100% on board. All right, so this is Jenny. Remember, Jenny is a ghost, right? Let's just quickly go through this. Remember, every ghost is supposed to give you some information about any crimes that's about to happen in any neighborhood. All right? All right, so this is the video I'm going to show you all here for those who are not familiar on how to bisect a line, how to cut a line exactly in half. I'm going to play it now. Sit back and relax. So what I'm going to do is draw a red line, right? We're going to try to cut that red line exactly in half. Right? You see that line we just drew, the black line? That cuts the red line in two exact pieces. So that means from here to here and from here to here is the same exact length. Like if the length of that line was 11 centimeters, here would be 5.5, and this portion here would be another 5.5. Right now in the exam, and I hope you all don't get these questions in the exam, right? It's a very rare question, but a lot of times you will need to do that in transformation questions. Right? So anyway, let's move on to the next slide. Right, so let's meet the next ghost over here. So we're done with Jenny. We have another ghost over here. You wait in the cemetery and you see another ghost. Right? And she's holding a very, very strange pendant here. So we're gonna hear her story and why does she keep saying she's sorry and whatnot. Let's see what went on in her life. All right, so do me a favor, right? You're gonna have to take down some notes here. We're going to have to find the center of rotation in this question. The question will come exactly like this in the exam if it were to come, right? The examiner will give you two shapes. One shape is the rotated version of the other. So it comes like somebody already rotated the shape. But you have to find where the center of rotation is. Is the center of rotation the origin, or is the center of rotation up here? There is a way to figure out where it is being rotated about. Okay? Take down the procedure for me, and then I will guide you through step by step on how to find the center of rotation. And I really hope you all don't get this question for your exams. It's not hard, but if you're not neat and good at drawing, it tends to be a little harder for those students who don't like to draw, right? But for those who like to draw and doing TD, this is going to be super easy. Anyway, take down this note here. This is how to find the center of rotation if it's not given to you by the examiner. Right. So what we, according to this, right, does everyone agree that if this is point A, after it got rotated, A ended up down here, you can see that this point is really this point. And if this was point B, where the 90 degrees was, when he got rotated, he ended up over here. And of course, if this is point C, C prime ended up over here. So you all can see the similarities between the points, right? What the points were originally and what it became after it was rotated. To figure out where the center of rotation is, like which point we are rotating this about, let's go to step one. It says to connect two similar points and bisect the line, right? So let's connect two similar points. You can choose A, B, or C. So you either connect the two A points, the two B points, or the two C points, right? So let's see which one I choose. I decided to connect the two B points. So I physically draw a line from B to B dash. You could draw a dash line, you could draw a solid line. I'm a big fan of using dash lines. I find it does look pretty cool, right? You could choose whatever you want. After I connect this, right? What did it tell us to do? It told us to do what with that dash line? To bisect the line. So let's bisect that line. Remember, I just showed you how to bisect a line. That's the thing with the compass. So when we bisect this line, does everyone agree that you're going to end up with a curve here and a curve here? Remember, we did that just now. And then you draw a line going through that bisection. I'm not going to be able to show that animation there. But when you bisect that line, do we agree that we will end up with this here? When we put the compass on this side and scribe an arc, and we go to the other side and scribe another arc, how much of you are with me so far? That when you bisect B and B prime, you will end up with two curved lines. Let me know. I'm taking it step by step, right? And I don't mind doing this one twice. I think I will have to do it twice. Great. What we're going to have to do now is take your ruler, and you see where the two curves meet. We're going to take our ruler and draw a long line through that. So let's do that. All right, so I'm going to draw the line through this last, because not to clutter the diagram. So what we're going to do now, right? I'm not going to draw the perpendicular bisector. The perpendicular bisector would be this line here, right? But I don't want to draw that line just yet. I'll draw that last because I don't want to clutter the diagram. Now we're going to do the same thing for another pair of points. So I can either choose the C's or I could choose the A's. It doesn't matter. I'm going to choose which one? The C's. And I'm going to do the same exact thing for that blue dashed line. I'm going to bisect that line. So I get out my compass and I scribe my lines. It will look something like that. You don't have to do it for the third point. You only need to do it for two sets of points. Through each one now, I'm going to draw the straight line. So look at this. So you see this one here? I drew the perpendicular bisector, and for the C's, where the two curves meet, I'm going to draw a perpendicular bisector, but I'm going to draw the line very long. You all notice that the red and blue lines, the solid lines, meet at a common point. That point is how much? That point is -5, -1. Look at it. -5 on the x-axis, -1 on the y-axis. That is your center of rotation. So basically, you're connecting two similar points and you're bisecting it. And you're repeating that procedure. And where the two lines meet will be your center of rotation. I want to do back this. I'm going to do it back twice for you all. Right? So let me stop the recording. I don't want the one that's twice on the record. All right, so let's see what's going on. Did we get her name? I'm not too sure if we got her name. I think I forgot the name. But anyway, let's hope her name pops up some. Oh, it's Joanne, right? Her name is Joanne, and she was born, well, she was living around 1845, right? You all see the word Romania. Which animal or which folklore creature do you associate with Romania. Right? Things like vampires and werewolves and stuff like that, right? So you know the story is going to have to do something with either a vampire or a werewolf or something like that, right? So anyway, going to be a werewolf at some point. So that's the werewolf there. Well, the wolf in Romania. That's Joanne screaming there. All right. So I think it's going to be pretty obvious that the wolf, even though she lived, the wolf bit her and it's going to affect her a little bit. All right. All right. So here's another question on how to find the center of rotation again. I'm going to do another example here, right? So if here's point A, I think it's fair to say when we rotate this triangle, this will be A prime. This is where A prime would end up. Here would be B. B prime will be down here. And if this is C, C prime will be here. All right. So let's see if you can remember the procedure. Well, what's the first thing we have to do? Let me know on the chat. Well, what's the first thing we have to do? Let's go through it. This will be the last thing we're doing for today. What's the first thing that we have to do? Connect two similar points. So it's either you connect the A's, you connect the B's, or you connect the C's. Quick question, does it matter which one we connect first? Do we have to connect the A's first? It doesn't matter, right? You could choose any pair. So let's see which one I chose. It seems that I chose the C's because the two C's were close to each other. So I say, hey, maybe that will make it easier. So when I connect the two C's, I have to bisect it. So when I bisect it using my compass, I get those curved lines. Obviously, I'm going to have to use my ruler to draw a straight line through those curves. But I'll do that last. Now I have to connect another pair of similar points. So I already connected the C's. I have to choose either A or the B's. Really does not matter. I connected the A's. All right, so I probably thought the B's were too far apart, and I probably thought that would have been too much headache. So let's bisect the blue line down here. And when we bisect it, we get those two curved lines. We're going to draw a straight line, a perpendicular bisector through both of them. Let's see what we get. All right. Red line, blue line. Tell me what the center of rotation is. You look at it there. What do you think the center of rotation is? But most people are saying, some people get it wrong. I'm just looking at the answers here. It's probably hard to see the numbers, right? Because the writing is pretty small. Don't the two lines meet over here? That's how much on the x-axis? 5. And how much on the y-axis? No, sorry. On the x-axis, it is what? 3. On the y-axis, it is 5. I mixed it up by mistake. Look at it. It's 3 on the x-axis and 5 on the y-axis. So the center of rotation is 3, 5. All right. Right. So that's 2 examples we did on finding the center of rotation, right? I suspect there will be more next week.